Good morning, Math AH. This is lesson 7.2C. Remember, we skipped 7.2B and just did the ninja video on the cross sections. And now we're going to talk about nets. When I think about nets, I think about wrapping paper. If I wanted to wrap a shape perfectly with wasting no wrapping paper, how would I wrap it? So here I look and it says, look at each net below, trace the outline of one base, name the object that was created and the net that's folded. Can you create congruent pentagon cross sections? If so, describe them. If not, explain why. So I'm looking at this, I'm thinking, how would it fold up? And I saw that they're all the same shape. They're all squares. So that's going to be a cube. And I need to label my base or trace or outline. I'm just going to color it. So here, this would be, they can't be next to each other. So I'm going to say this is one of my bases and this is one of my bases. But some people like to do this one too. I could have just done like here and said here, this is going to be one of my bases and this is going to be one of my bases. When they're all the same shape, as long as you don't pick two that are next to each other, you want to pick them so when they fold up, they'll be opposite. You'll be fine. Okay, so here I know that my base is a square, or if you think it's not a square, you think it's a rectangle, fine. Then you're going for a rectangular prism. I'm going for a cube. Either way. So here I'm going to say, hey, that would be folded up into a cube. And then I think about a cube. If I took a big butcher knife and cut it, would everybody get the same size slice? So yeah, if I sat there and cut, everybody would get same size slice, and the slice would look like a square. So everyone could get exactly the same piece. So here, can you create congruent parallel cross sections? If so, describe them. If not, explain why. So my answer is yes. The slices would be squares. It's a layer of squares. I need to get my little screen up there. Okay, so if I have a cube, I'm going to draw a cube. It might not be that pretty, but here we go. Here's my cube. And I take my butcher knife to slice it. I'm going to have layers of squares. Yeah. So here, type your answer. Yes. It is made from layers of squares. My typing font is huge. I don't know why. Let's see. Oh yeah, I don't need it 14. Let's try. There we go. Okay, next one. I see a rectangle. I see two circles. So I know that my bases have to be the odd shape, which is the circle. That's my base. And that's my base. So they would be opposite each other. And then this lateral face, this is the lateral face. This part, lateral face, it's going to wrap around and I would get a cylinder. Okay, so the object here is the cylinder. And again, I have to think, is there a way that when I slice it, can I get congruent shapes? So here, yeah, if I slice it this way, no, I can't. I would get a segment here and then bigger and bigger and bigger rectangles and the smaller and smaller rectangles. But if I turn it this way, I could get congruent slices. Every time I sliced it, someone would get a circular slice. So yes. Yes, it is made from layers of circles. Whoa, my yes went away. Let's try that again. There we go. Okay, so again, I'll give you my lovely drawing. Here's my cylinder. Woohoo! And when I cut it up, I would get layers of circles. All right, moving down the page. Okay, I want you to try 3 and 4, and then we'll check back in. So pause the video, try 3 and 4, and then check your answer. Okay, so number 3, I see my triangular bases. So it's a triangular prism. I know it's a prism because there's 2 bases. And here, yeah, I could slice it up so I would get a bunch of triangles. Again, if you have a triangular prism, you can slice it this way and chop, 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 chop. You're going to get a bunch of triangles. The next one, we have a square pyramid. If you call it a rectangular pyramid, fine. It's not marked necessarily congruent. So here I have a square pyramid. So the base is the square. The other sides are the lateral faces. And here, if I go ahead and I think about my square pyramid, I'm going to draw the front and the base, and then the apex connect down. My backside would be dashed. If I sit there and chop it, this person gets a square. And this person up here also gets a square, but they're not the same size square. They would be scaled down. It would be similar. It wouldn't be congruent. So right here, this square that gets chopped and this square up here that gets chopped are not the same size. They get smaller and smaller. So no, you're not going to get congruent parallel shapes. You're going to get similar parallel shapes all the way until you get to the apex, and then you would just get one little dot, a crumb. Okay, next one. Okay, you're going ahead and trying 5, 6, 7, and 8, and then come back and check your work. All right, number 5. I see my bases. I see one here and one over. Actually, I don't like that base. I could choose that one, but I like this one better. I'm going to call this one my base and this one my base. They're different than the other ones. Okay, you could have called 2 other sets your bases. It doesn't matter. It's a rectangular prism. I like those 2. And yeah, I would get layers of rectangles. When I have a rectangular prism, I can cut parallel to the base. I get layers of rectangles. The next one, that is a triangular prism. Here are my bases. And again, on the triangular prism, if I cut it, I'm going to get layers of triangles. Number 7, I have a hexagon. Hexagon is my base, so that's a hexagonal pyramid. And remember, on the pyramids, we don't get layers of the same shape. We get smaller and smaller and smaller and smaller as we go to the apex. So no, hexagons are not, you get hexagons that are similar and not congruent. Next one, we have a prism because I have 2 bases. The pentagons are my bases. So yes, I would get layers of pentagons. Okay, now I can turn the webcam off. Here I go. Moving down the page. Surface area is the sum of the areas of all faces and is measured in square units. Volume, on the other hand, is the amount of space. I hate that. It's the amount of cubes inside a 3D object that is measured in cubic units. Okay, the net to the right forms a cube. Each square face has a length of 4.2. What is the surface area of the cube? So when I'm doing this, I think, hey, there are 1, 2, 3, 4, 5, 6 rectangles that are all exactly, 6 squares that are all exactly the same. So I have 6 squares. I got to find the area of each one of those squares. So that's 4.2 times 4.2, because it says that each length is 4.2. And when I multiply those, I get 105.84. We're doing surface area. So our area, we're going to have centimeters squared. Okay, next, volume. What is the volume of the cube? To do the volume, we always do area of the base, times the height of the prism. So if I have a cube, the base is 4.2 by 4.2, and the height is also 4.2. So for the area of the base, I'm going 4.2 times 4.2. For the height of the prism, I'm going 4.2. So when I multiply 4.2 times 4.2 times 4.2, I get 74.088, and now I am in cubic units, so centimeters cubed. If you created a new cube with edges that are 150% of the original cube, what would the new surface area and volume be? Okay, so here I am taking my shape that I had there, and I'm increasing it by 150%. So if I'm increasing it by 150%, that means I'm multiplying it by 1.5 because 150 in decimal form is 1.5. So I'm multiplying each side by 1.5. So now my new cube, 4.2 times 1.5 is 6.3. All of these are 6.3. Okay, so for the surface area, I had 6 squares, and each of the squares was 6.3 times 6.3. So I get 238.14. What are my units here? My units are centimeters squared. For my volume, I go 6.3 times 6.3 times 6.3, the area of the base times the height. And when I do that, I get 250.047 centimeters cubed. A different way that I can do it is I could take the original surface area. So my original surface area, I have to look back at what my number was. So looking back, my original surface area was 105.84. And if the scale factor is 1.5, then the area ratio is 1.5 squared. So I can multiply by 1.5 squared, and I would also get 238.14. Okay, different way on my volume. My old volume was 74.088. If my scale factor is 1.5, then my volume ratio is 1.5 cubed. And if I do that, I get 250.047 centimeters cubed. So a different way to do it. I can either use my ratios, or I can just increase the sides and calculate it. Either way would be fine. All right, how about you try D, pause the video, and then we'll talk about it. Okay, so I took the old surface area and I multiplied by 0.7 squared because you're doing 70%, which is 0.7, but it's area ratio, so you have to square it to get 51.861. You could have also took your original sides and multiplied by 0.7, so you have a new cube by 2.94, and you go 6 times 2.94 times 2.94, you'll get the same answer. My volume, I took my original volume and I multiplied by 0.7 cubed again. We have to cube it when we're doing the volume ratio. I get 25.4122, or I shrunk it down by my sides and I multiplied 2.94 times 2.94 times 2.94. Either way will get you there. All right, number 10. Katie purchased a box of crackers from the deli. The box is in the shape of an isosceles triangular prism. Okay, what does isosceles mean? It means that two sides are congruent. So if this one is 15, that's obviously not 15, then this side over here has to be 15. Okay, so we have to work with that word isosceles. Prism, that means that we have two bases that are the same. So here I know that this front is my base, and the back side over here, that is my base. Okay, the other thing we have to pay attention is the height of the prism. The height is not how far it is off the ground. It's the distance between the bases. So here, this is the distance between the bases. So this is the height of the prism. Okay, the base is not always what's on the ground. It's the two shapes that are not the rectangles. So we have to pay attention to that. Okay, so how much packaging material was used to construct her cracker box? So it's asking me for, like, if I was going to wrap it, I'd have two triangles I'd have to wrap, two triangles, and I would have three rectangles, but the rectangles are not all the same shape. So I have my left and my right, those two are the same. So I'd have two of the left, right, two rectangles. And then I'd have one rectangle on the bottom. It has different dimensions, the bottom rectangle. So I have to pay attention to those things. Okay, so to find the area of the triangle, I have two of them. And area of a triangle is 1/2 base times height. So 1/2. The base of the triangle is 18, and the height of the triangle is 12. So I have 18 times 12. Okay, my left and my right rectangles are 30 by 15. So 30 by 15. So I have two rectangles that are 15 times 30. And my bottom rectangle is 30 by 18. So I have one rectangle that's 18 by 30. And then I have to go and I need to calculate all those numbers. So 18 times 2 is 36. Half of 36 is 18. 36 times 2 is 70. Oops, I put a 2 there. I think I wrote that wrong. That's a 12. It just didn't come up when I put my pen down. Let's go again. That's a 12. Okay, there we go. Okay, so the 2 and the 1/2 are going to cancel out. And 18 times 12 is 216. So I got 216. Then I have 2 times 15 times 30. So 30 times 15 is 450. 450 times 2 is 900. Then I have 18 times 30. So I know 3 times 18 is 54. So that'd be 540. So I'm adding all that area up, and I get 1,656 centimeters squared. What is the volume? I have to do area of the base times the height of the prism. Well, remember the base is the triangle. So here I have to go area of the base, 1/2 base times height. So 1/2, the base of the triangle is 18, the base length. The height of the triangle is 12, times the height of the prism. The height of the prism is not 12, it's the distance between the bases, which is 30. All right, so I'm working that out. I have 2 goes to 19 9 times. 9 times 12 is 108. 108 times 30 is 3,240 centimeters. This is volume, so cubed. All right, next page. These ones are a little trickier. I have to think. I don't just have a regular shape. I have a triangular prism stacked on top of a rectangular prism. So I have to see, how do I see the shape? I see a triangular prism stacked on a rectangular prism. Triangular prism stacked on a rectangular prism. Okay, and over here, I also seen the same thing, a triangular prism stacked on a rectangular prism. I'm not sure if I can control copy this. I'm gonna try. Yep. All right, how many surfaces are on this shape? So we can't we can't count what's not showing. So in between that triangle is not showing. So on the triangular, what I see showing here is I see this lateral face and this lateral face and the base and the base. The other lateral face is not showing. So from the top, I see a 4. Okay, here I'd have the front, the back, the left, the right, the bottom. And then I'd have these 2 little sections here. 1, 2. So front, left, right, bottom, and the 2 on top. There's still 6, but it's not a solid 6. Sorry, 7, because we split the top in half. So I see 11. Find the surface area and the volume. So I need to kind of plan out what I am doing. So for my surface area, I'm going to first pay attention to the rectangular prism. I have a front and back, and they're the same. So I need my front and back of my rectangular prism. Front, back, rectangular prism. And I have a left and right that are the same. Left, right of the rectangular prism. And then I have a bottom. And then I have the top, but the top's kind of cut up. So on the top, I'm just counting these 2 side rectangles. So I have a separate top I need to pay attention to. So it's not the whole top, it's a cut up top. Okay, so for the front and back, these are 19 by 11s, and there's 2 of them. So I have 2 times 19 times 11. And for the left, right, I have 2 of them, and they're 9 by 11s. So I have 2 9 by 11s. And then for the bottom, it's a 19 by 9. And then for the top, if I'm looking at it, if all the way across is 19 and we take off 10, then what we have left is 9. And they are by 9, so 9 times 9, or you can say 2 times 9 times 4.5, whichever way you like. So I'm going to say that there are 1 9 by 11s. No, 9 by 9s. Then I have to take attention to the triangular prism on the top. Again, on the triangular prism, I have a front and a back, and then I have a left and a right. The front and back, that's a base of 10 and a height of 12, and it's a triangle. And the left and right are rectangles. There's 2 of them that are 13 by 9s. So for the triangular part, I have a front back. Front back. There's 2 triangles, and the triangles are base of 10 and a height of 12, and I have to divide by 2. But I have 2, so those 2 are going to cancel out. And then I have a left and a right. Left, right. Okay, and the left and right on the triangles are 13 by 9s. 2 13 by 9s. Oops, I put a times. That should be multiplied. Okay, and then I have to go through and calculate all these lovely numbers. Okay, so 2 times 19 times 11, that's 418. 2 times 9 times 11, that's 198. 19 times 9, that's 171. 9 times 9, that is 81. Then I'm to my triangle. Here, these 2's are going to cancel out, so that's 120. And then 2 times 13 times 9, that is 234. Then I got to add up all my numbers, and I get 1,222 feet squared. Now I have to do the volume. So for the volume, I have to find the volume of the rectangular prism. Or actually, I can do area of the base times the height. So what I can do is I can say that the funky shape is this whole little house dude. This is going to be my funky shape. This is going to be this part, and this part is going to be my base. And then everything is layers of that. So I really can call that funky shape my base, and then just multiply by the height of the prism. And in that instance, the height of the prism would be 9. Or you can separate the two shapes and then add them together. So if I look at my funky shape, my base is this kind of weird house kind of thing. That's my base. And then the area, the height of the prism is 9. Base times the height. Okay, so I just have to figure out what the area of this little guy was. So this was 19 by 11 on the rectangle part. So here that was 209. And the triangle had a base of 10 and a height of 12, and I have to divide by 2. So that was 60. So when I add those up, that's 269 for the area of the base times my height, which is 9. So I get a total of 2,421 feet cubed. Okay, I want you to try number 12. Pause the video and then check back for your answer. Okay, so when I'm looking at this shape, I see that I have a rectangular prism stacked on a triangular prism, or a triangular prism stacked on a rectangular prism. The top of the rectangular prism is hidden. It's not showing. So there's 5 faces coming from the rectangular prism. The bottom of the triangular prism, that's not showing. So we have 4 faces coming from there. So we have a total of 9 faces. So when I start doing surface area, I think that rectangular prism has a front and a back I need to pay attention to that are the same. It has a left and a right that are the same. And then it has a bottom that's by itself. Okay, so down here, when I was doing my work, I had a front, back, a left, right, and a bottom. There's 2 for the front, back, and they're 8 by 5s. There's 2 for the left, right, and they're 5 by 17s. And there's 1 bottom that is 8 by 17. So the rectangular prism, I've got an 80, a 170, and a 136. Then I went and focused on my triangular prism. Again, I have a front, back that are triangles. They're the same. And then I have 1 face on the hypotenuse and 1 face on that back leg that are different. So I went and calculated my numbers. So here I have my front, back triangles. They're 11 by 8s divided by 2, but I have to multiply by 2. I have a hypotenuse rectangle that's 18 by 17, and then I have a leg rectangle that's 11 by 17. So 88 plus 306 plus 187. I added up all my orange numbers to get a surface area of 967 inches squared. Okay, volume. I want to find the area of the base times the height of the prism. So when I looked at this funky shape, I made, let me erase my dots here. I thought of this as my base, this trapezoid or this rectangle with a triangle on top. That's my base. And if that's my base, I know it's my base because I have another one right back there. So they're parallel and they're congruent. If that's my base, then the height of my prism is the distance between my bases. So this right here is my height of my prism. Okay, so when I went and found the volume, I did area of my base times the height of my prism. So I'm going to scroll down here. Okay, my base down here, that was an 8 by 5. So for my little rectangle on the bottom, I got a 40, 8 by 5. And for my triangle, that was 8 by 11, but I have to divide by 2 because it's a triangle. So 8 times 11 is 44. So 40 plus 44 is 84. And then I have my height of my prism, which is 17. So when I multiplied that, I got that my volume is 1,428 inches cubed. All right, you are ready for your homework. Bye.